Dear students, you are welcome to RK Institute. I am Dr. RK Saini and today I am going to discuss formation of covalent bond. Dear students, covalent bond is formed by the sharing of electron orbital in which unpaired electrons are there, then they can overlap and make a covalent bond. First, we discuss how can formation of a covalent bond, then what conditions are essential or suitable for the formation of covalent bond, next types of covalent bond, and then I explain relative strength of covalent bond. First, how can formation of a covalent bond, then conditions for the formation of covalent bond. Then I will explain types of covalent bond. And then explain relative strength. Relative strength means bond strength of covalent bond. So first, I will discuss formation of a covalent bond. Covalent bond is formed by the overlapping of orbitals which contain unpaired electron in proper orientation. And orbitals may be atomic or may be molecular orbitals, may be atomic orbital or may be molecular orbital, or maybe molecular orbitals which contain unpaired electron take part in process of overlapping. For example, in case of H2 molecule, 2 hydrogen atom, 1 hydrogen atom has 1 electron in s orbital and another hydrogen atom also contain 1 electron in 1s orbital. The condition of atomic orbitals which contain unpaired electron, they approaches to each other in proper orientation and electrons must be have opposite spin by which their lobes, for example in s orbital, they overlap to each other in which maximum electron density accumulate between the nuclei of bonded atom along with axis. Then it is known as sigma bond. Molecular orbital also contain unpaired electron. For example, we check a covalent bond formed between carbon in C2H6 molecule. C2H6 molecule in which 2 carbon atoms contain 1 sigma bond also, and this sigma bond is formed by the overlapping of sp3 hybrid orbitals, because the carbon has sp3 hybridization. Each carbon has sp3 hybridization, and hybrid orbitals can also make covalent bond. For example, this carbon sp3 and another this carbon is also sp3. Therefore, this sigma bond is also formed by the overlapping of molecular orbitals. I think that is clear. It means covalent bond is formed by the orbital which contain unpaired electron with opposite spin, and the orbital overlap or approaches to each other along with internuclear axis by which their maximum electron density centered between the nuclei of bonded atom, and this is known as covalent bond. Now we discuss types of covalent bond. On the basis of overlapping and accumulation of electron density, covalent bond are 3 types. Covalent bonds are 3 types, namely sigma bond, pi bond and delta bond. Sigma, pi and delta. And in all bonds, 2 orbitals. First, all bonds in which unpaired electron present in 2 orbitals. These orbitals may be molecular orbital. 2 orbitals either sigma bond, either pi bond, or there is either in delta bond. Two orbitals which contain unpaired electron make a covalent bond. In all cases, maybe sigma, pi, and delta. And these orbitals are overlap in proper orientation. Proper orientation means the atomic orbital or molecular orbital which approaches to each other along with one axis or internuclear axis. If nothing is mentioned, then we taken Z is internuclear axis, and they approaches along with internuclear axis by which electron density is centered between the nuclei of bonded atom. Then it is known as covalent bond. On the basis of accumulation of electron density, there are three types, namely sigma bond. In case of sigma bond, electron density centered along with internuclear axis. For example, SS overlapping. S atomic orbital and S atomic orbital, these are known as SS overlapping, and electron density centered between the two nuclei along with internuclear axis. Then therefore such type orbital is known as molecular orbital is known as sigma bond, or we can say it is sigma bond. Is it formed by the SS overlapping, or it formed maybe PP overlapping, SP, DP. For example, it is PZ orbital because we taken Z is an internuclear axis. Therefore, this orbital is PZ. Now, it is S orbital. The electron which contain in opposite direction and one electron. Therefore, they overlap by which electron density centered between the nuclei of bonded atom along with internuclear axis. Therefore, it is also sigma bond. Another example of sigma bond. Therefore, it is known as PS overlapping. Now we check DS overlapping. This orbital is DZ square orbital. DZ square orbital. It contains one dumbbell along with Z axis and another dumbbell make a circular link in XY plane. Therefore, this orbital is DZ. We taken Z is internuclear axis. Therefore, DZ and one S orbital are overlapped to each other and make also a sigma bond. And the definition of sigma bond is the electron density centered between the nuclei of bonded atom along with internuclear axis. Therefore, it is also known as sigma bond. Sigma bond. D and S overlapping. Now we check pi bond. Pi bond is formed by the sidewise overlapping of orbitals, namely atomic orbitals. Most of the cases, hybrid orbitals make pi bond except benzene. In case of benzene, pi bond is formed by the sp2 hybrid orbitals. However, in most of the cases, hybrid orbital make a sigma bond. For example, pi bond is formed by the atomic orbitals. This orbital is px orbital because px or py. Because we taken Z is an internuclear axis. When px and another is px, it is known as proper orientation. Otherwise, overlap. Atomic orbital lobes are not overlap in proper direction. These orbital contain unpaired electron in opposite direction. For example, this orbital contain electron in clockwise and another orbital contain electron in anti-clockwise. We know that p orbital is a dumbbell, and when they approaches to each other, then their lobes are overlap above and below to the molecular axis. Above and below to the molecular axis. Therefore, electron density. How many electron in this bond? Only 2 electron. In every type of bond, maybe sigma, pi, and delta, only 2 electrons take part. When both electrons are centered along with internuclear axis, then it is known as sigma. When both electrons divide into 2 parts, above and below, then it is known as pi bond. And pi bond is formed by the sidewise overlapping orbital. For example, px and py. Then they make a pi bond. And hence pi bond is a weak bond in comparison to sigma bond because electron density divide into 2 parts, above and below to the internuclear axis. Therefore, we can say nucleus repulsion takes also dominant in pi bond rather than in sigma, and as pi bond is a weak bond, electron density divide into above and below in two parts. In case of delta bond, d orbitals take part in d delta bond formation, and hence such type bond is formed present in complex species. This delta bond is formed by the face-to-face overlapping of d orbitals, delta bond. For example, this orbital is dx square minus y square. The orbital is dx square minus y square. This is suppose x axis and it is y axis. Now the z axis above to the plane. If we taken x and y axis are plane, then it is known as z axis. Another d orbital with z axis are overlap, and hence their four lobes are parallelly overlap to each other. For example, this lobe overlap with this lobes. Similarly, this lobes overlap with this lobes, and similarly lobes of x orbital are overlap to x orbital, and hence delta bond is formed by the overlapping of two d orbitals face to face, and we can say 8 lobes are formed by the 8 lobes are overlap or meet in proper direction. Suppose this is the z axis and it is the sigma delta bond. Therefore, delta bond is formed by the overlapping of two d orbitals in face-to-face overlapping. Some another examples in which overlapping between orbitals are takes place. For example, one is px orbital and s orbital. Which type of bond is formation? Taken z is an internuclear axis. Suppose this is z axis, and hence px is perpendicular to the z axis, and s is non-directional orbital. Therefore, no bond formation, because their interaction is not change into bond formation, because the lobes of p orbital are not overlap with s orbital. Because when s orbital overlap with p orbital, that is the point is known as node, where probability to finding the electron density is almost zero. Therefore, no interaction during the formation of covalent bond. Similarly, when dz square orbital and dz square orbital are overlap, then they make a sigma bond. dz square orbital, it is dz square orbital, and another dz square orbital. It is only one dumbbell, because one dumbbell change into circular ring along with x and y axis. Therefore, their overlapping make also a sigma bond. Head-to-head overlapping, sigma bond. Similarly, the orbital of dxy and dxy overlap along with z axis, then they make a delta bond also. Please check the formation of delta bond. This orbital is suppose dxy, because their lobes, double bond and lobes present in the plane of xy plane along with between the axis, and this axis is z, and another d orbital dxy is this type. When these orbital is the x and y, and this is z, when z axis are meet to each other, the orbitals are overlap. There are 4 lobes of one orbital and 4 lobes of another orbital. For example, when these orbitals comes to each other or nearer to each other in proper direction, means z axis, then these lobes 2 and 2, 4 this lobes with that, and this lobe with that, and as 8 lobes are formed, overlap, and it is also known as delta bond. Similarly, Some another examples are also checked and identify proper orientation. For example, dz square and pz. Which type bond is formed? We know that it is the dz orbital. dz square and it is pz, and their head-to-head overlapping and formation of a sigma bond. Now another example of dz square and px. No bond interaction because it is dz square orbital. dz square orbital, it is we taken z internuclear axis, and it is maybe px or maybe py. No interaction, therefore no bond formation, because their lobes are not overlap in proper orientation, and hence no bond formation. Another example, we taken another example and identify types of bond formed between the orbitals. For example, one orbital is dxz and pz. We know that we taken is z axis, and hence this orbital is pz. This is z axis and we taken x axis. So this orbital is xz and pz. pz orbital means the lobes of p orbitals along with z, and has no interaction. Therefore, no bond formation takes place. No effective overlapping takes place because the interaction is not in proper direction. This is z axis, pz, and this is the x axis. Therefore, the orbital is dxz. No bond formation. Another example. dxz and px. Similarly, the orbital is dxz. This axis is taken to be z and it is the x. And another orbital is px. It is px because this axis taken to be z. When these orbitals are overlapped to each other, then sidewise overlapping takes place, and two lobes along with above and below to the axis are overlap to each other, and as they gives pi bond formation. It is the pi bond. Therefore, their overlapping is in proper orientation and generate a pi bond. Another example, one orbital is yz and py. yz is another double orbital, and their lobes lie along with z and y axis. It is also planar. This orbital axis taken to be z, and as this is the z and it is yz, and now we taken py orbital. It means it is also perpendicular to the z axis. When they overlap or interact to each other, then generate pi bond because sidewise overlapping takes place, and hence pi bond is formed by the overlapping between two orbitals in sidewise direction and generate pi bond, and in which electron density divide into two parts, above and below, to the internuclear axis. And these are the examples of pi bond. Now we discuss their relative strength. We know that sigma bond is formed by the overlapping of atomic orbital or molecular orbital in which electron density is centered between the internuclear axis along with internuclear axis. That is known as sigma bond, in which nucleus repulsion is minimum and maximum attraction between nucleus and electron density. Therefore, it is the strongest bond. Now, in case of pi bond, in which electron density divide into two parts, above and below to the internuclear axis, it is pi bond. In case of sigma bond, and in case of delta bond, electron density divide into four parts, means overlapping four parts, above, below, left and right, or we can say internuclear axis surrounded by electron density in four directions. This is known as delta bond, and hence delta bond is more stronger than pi bond. Therefore, sigma bond, then delta bond, and then pi bond are relatively strength of covalent bond, because in case of delta bond electron density divided into 4 parts and internuclear axis surrounded by 8 orbitals, and as delta bond is comparatively stronger than pi bond. It is the relative strength. Okay, and this is the topic